Hello, dear students. Today we are going to discuss the OSI model, which is the basic model for computer networking. We have been studying a lot of things regarding computer networking in this particular course, and this particular model is really useful and it lays the foundation for computer networking. Just to tell you, OSI stands for Open Systems Interconnection. So it's a short form, and its long version is Open Systems Interconnection. This particular model was first introduced in the late 1984 by the organization called as International Organizations for Standardization. International Organization for Standardization, which is popularly known as ISO, because you might have heard this word several times in your daily life, like your pressure cookers or washing machines, all those are ISO compliant. So the same organization is actually behind this particular model, and that's the ISO organization. So what this organization has done, it has outlined what needs to be done to send the data from one computer to another computer. You know that computer networking is nothing but the transmission and reception of data over long distance. And this particular model has outlined in detail the process so that the data can be sent from the sending machine to the destination machine without any errors and with certain protocols. So that is the main essence of this particular model. So this model also specifies how this data transfer needs to be done or how it is to be done. And behind this is the protocols. We have seen protocols, the meaning of protocols. These are the norms of communication. So when data is starting, when data is stopping, the frame contains how many bits. So all these are protocols, and this particular model specifies the more protocols for data transfer. Now, this particular model has divided the data transmission and reception in a very systematic process. And this systematic process, which is again laid down in number of steps per process. And these number of steps and the processes, they are categorized into seven different systematic layers. And these seven different systematic layers forms the ISO model. Now, these seven different layers, they try to interconnect with each other so that the entire task of data transmission and reception is accomplished in this particular process. So therefore, this is not a standalone process or standalone protocol. It comprises of lot of layers, and those layers they interact with each other. Now let's see. You can see on the screen what is this particular model. So as we have seen, this model is called as OSI reference model because it is the reference model for the entire data networking or computer networking. Another important thing I would like to make a mention here is that this is a theoretical blueprint. So the practical task of data transmission and reception is little different than what is done in the OSI model because this model was specified way back in 1984, and this model is nothing but it's the just a theoretical blueprint. So which has categorized the task of data transmission and reception in different steps and in different layers so that one can systematically analyze how this entire process takes place. This model also helps to develop standards so that the entire hardware and software is developed systematically because you know that the computer networks they are part of global phenomena because just take an example of internet. It's a global spread network, and in such a global spread network there might be some local vendors and they are developing the hardware and software. So then there has to be some kind of unanimity or some kind of compatibility, some kind of compliance of the standard, and therefore this particular compliance of the standard is maintained by using this particular model, and therefore this model is followed as a blueprint of the data transmission. So as a whole, this model aids in standardization of networking technology. Standardization is very important because when one goes from continent to continent, what's important is certain standards they need to be followed, and these standards need to be maintained. And therefore, this standardization is actually the compliance is done by this particular model. And it also provides the organized structure for hardware and software, how it is developed, what kind of compliances needs to be done, what are the specifications and whether those specifications are compatible. So all these things are taken care by this particular model. So we have seen what is OSI model and what is this particular model. Let's come to little details of this model. This is a reference model. So what is the meaning of reference model? This model outlines certain rules and protocols which are used for communication between the computers which are way apart and which are actually connected by different kind of networks and so on. So therefore, this serves as an outline of rules, and these rules are need to be followed by each and every network that is in between the sending computer and the receiving computer. Here in this model, it comprises of 7 layers, and each layer has got its own functions. What the layer is supposed to do, how the layer is supposed to pass on the data to the layer which is just above that particular layer and which is just below that particular layer. Everything is very very detailed, specified in this model. So therefore, every layer has got its own functions and it provides supports to other layers. So no layer is working in isolation. It has to work in collaboration with the other layer, and therefore this particular model is known as the reference model. Now, this model has given rise to some other models also, and which are much practical. So, one of the most well-known model is the TCP/IP model. TCP/IP stands for Transmission Control Protocol, Internet Protocol. So, this is again a reference model, which is a very very popular model and used widely in computer networking. Why this model? Why this particular 7-layer model? So, I would like to just convince you that this model is because of the complexity of the networks. Because when the networking particularly started in 1980s, it was just a small phenomena or small organization. However, when the computing requirements they increased, getting more and more computers in the modern network, so therefore it just evolved as a very very complex network. And then again, in the multiple vendors they came into the picture. So when multiple vendors came into the picture, that means many people they'll be designing the hardware and software in different parts of the world. Now you will agree with me that unless these these people, these vendors, they are developing the hardware and software in different parts of the world, unless this hardware or software they effectively talk to each other, the data transmission will not happen. So therefore, there is a much need of compatibility in every part of the world wherever the network is spreading, and this compatibility has basically given rise to this particular model. Because if you want to maintain the compatibility, then you have to agree upon certain specification. You have to agree upon what the device in a particular part of the network is supposed to do, and then what its counterpart will be doing the same thing in different network. So therefore, this all agreement is required, and this requires a lot of standardization. This requires a lot of maintaining the compatibility between the models, between the devices, between the hardware, between the software. So therefore, this gives the rise to some kind of agreement between the different vendors, and this is, then you will agree with me that this is the basic sole reason why this 7-layer model has been developed. So the basic reason behind developing this model is the advancement of the technology and complexity of the modeling. Now, why 7 layers? That is another question you might be interested in. So, you can have single layer model. Okay, you can see on the screen that even a single layer model is possible. And this single layer model is having one device, the transmitting device on the left hand side, and the receiving device on the right hand side. Now, these devices they are consisting of the hardware and software. The hardware is something like the network interface card, the basic processing unit, and so on and so forth. The software consists of the stack of the protocols, which is behind this communication between these two computers. And this can be connected by using dedicated copper wire or radio link. Okay, and the hardware and software actually they work with each other so that this entire operation of data transmission reception becomes hassle free. And therefore, you need to have single specification for the entire communication process. As I mentioned, when the data transmission starts, when the data reception is received, then what is the bit width, what is the bit voltage, what is the current behind the bits, or what is the timing, the synchronization. The entire part is required to be worked out, and this is part of the specifications. So therefore, if you want to work out the specification, then you need to have this kind of model. And we have seen that single layer model is something like this. Now, when you go from single layer model to the two layer models, you can see in the picture that this is a two layer model. Now, the problem is the single layer model, if you want to specify the entire transmission and reception operation, it becomes so complicated that you can't specify the entire thing in a single layer model. So it's better to have two layer model. In this two layer model, you can very well categorize that what are the technical standards, what is the applications, and then the applications, you will agree with me that applications were being developed to run over ever increasing number of media and signaling systems. Because in the single layer model, we have just seen a copper cable or a radio link, but now there are so many media which were evolved over the time, like fiber optics or the IR pair of transmitter transceiver. So many media now they are doing this operation. So the solution is separate application aspect from the technical aspects. So in this two layer model, you have at the bottom the technical standards and on the top the application layer. What the application layer is doing, the application layer is actually interfacing with the user. When the user wants to do the transmission, the user can simply have a web interface or something like that, and then the user can just start the process with the click of the button. So that is the application, and behind this application there are technical standards, so they will actually take care of so many things what the user intends to do. So in a way, this two layer model, the functionality is better than the one layer model. Now, from this two layer model, the developers they thought that again it is a bit clumsy that the entire thing cannot be specified even in the two layer model. So which has given rise to four layer model. So you can see here the four layer models, which consist of the application at the top and the technical standardization, which we discussed in the two layer model. Again, it is split into three layers, like the physical layer, data link layer, network layer. Now, very soon we will be coming out with the functions of these layers. So don't worry at this part of time. So we'll be doing it in the next video. But this in this four layer model, the things are pretty clear because the functions are divided amongst the layer. And you can see that the transmission side, which is left hand side, and the reception side on the right hand side, the layers they talk to each other, which is the essence of this model. So therefore, this particular model is called as peer-to-peer communication. So peer-to-peer communication means every layer on the transmission side will talk to its equivalent on the reception side. So that is peer-to-peer. So these are equivalent layers. In these equivalent layers, they will talk to each other. So the things become very much clear, very much specified, very much divided, because you will agree with me that when the things are complex things are divided, then you can do it better. So the same thing is the basic principle behind this layering, that the entire complicated task of the data transmission and reception is divided into simple steps, and then the steps are categorized, and then the steps are given per layer, and in this way the entire layering has been developed, and this is the basis of this particular model.